Right. So what we did so far, we created a repository. We have seen end-to-end, deploy it and manage it, and we have seen online offline mode as well, where we can operate the repository in online mode, which means you're directly opening a repository that is deployed onto the server, and you are using that repository. So we have seen all these approaches, and kind of we got a comfortability in how do we deploy and manage our repository and modify our repository. So let's start using more in terms of the repository features. So try to enhance our repository and do something kind of a better way of doing the repository, knowing the things within the repository in detail, and kind of what are the alias tables, what are the logical tables, what are the logical table folders and mapping. So far, like we are simply dragging and dropping, but we would need to understand if we have to create them manually, how do we do? So we'll do all those things now, so that we'll have a little command on developing the repository. Okay, so I go to the administration tool. So there are two ways that I can modify a repository at this point of time. One is I can open the repository in online mode, or I can create a repository in offline where I can create a new repository. So what I would like to do is I would like to build a new repository now, because I totally want to get rid of the physical layer, because so far in the physical layer we are using direct tables to create a model. So now what we do is we introduce another thing which is called alias table. So when you're kind of totally changing your repository and changing too many objects and modifying too many things, so online mode is not really suggestible, because in online mode it doesn't really expect you to mess around with repository. It expects you to do the changes in a systematic way. Maybe you can create calculations, you can modify calculations, but if it is something to delete the total setup and recreate those kind of things, it's not suggestible to do in online mode, because sometimes it will fail to commit the changes. So since the change is something that we would like to do, where we would like to recreate the stuff, so either we open the repository in offline mode, that is one thing, or totally create a new one. So probably now I can open the repository in offline mode. So I can say open offline, which is when I say open offline, what is that I'm trying to do? I'm just trying to modify my repository without the consent of the server. So server is not got nothing to do with it. Okay, so I can open my repository in offline mode. Whatever the changes that I want to do, I can do my changes. Okay, now once I am done with my changes, once I am ready with my changes, so what is that I'm gonna do? I'm gonna deploy the same changes to the server. So till the changes are deployed, the server is not bothered about what you do with this repository. So you do anything with this repository, if the repository is working or not working, consistent, not consistent, it is not going to impact your existing runtime, in the sense existing repository that is running on the server. So that way you open any repository in offline mode, you do any changes, so that's kind of a development. Unless you deploy, you are not going to get affected by those changes. Okay, so let's open this repository in offline mode. Right, so if you look at here, you have a couple of repositories available here. So this is 001, 57, 56, 57. Now from our understanding, the latest repository is what? 57, which means this is the one that should be configured now. So if I go to the enterprise manager, if I see what is the repository that is being used by the server, so it should be 57. But again, in offline mode, I cannot really kind of if you see sorry guys. Right, so now If you see here, 57 is the latest repository. If I go to the enterprise manager and if I see, this is my enterprise manager. Usually the latest counter, whatever the counter that you see, right, that is the repository that is deployed onto the server. Otherwise, I can also navigate here, instance 2 and BA foundation. I'll tell you how to navigate to this one later point of time. So I have repository. Within the repository, this is a 57.rpd is the latest one. Now, so if I go to the enterprise manager, if I go to the business intelligence core application, so I mean you should have very much comfort in navigating here and there and knowing the things, what is currently deployed and what is the current repository that is currently being used. These kind of things you need to know. See, this is 57 is the repository that is actually configured now. So let's assume one thing. So assume that this repository is actually configured now. What if I open the same repository in offline mode? Right, so this is the repository that is configured on the server. So which means the server is actually using this repository. Okay, so now when the server is using this repository, what if I would like to open it in offline mode? So let's try to open that repository 57 in offline mode. There is a 57, I say open. See, this gives an error. It's not an error kind of, it says that, this repository being used by the server. So it says this repository can only be opened as read-only. In the sense, you can open the repository. It will allow you to open the repository, but it doesn't allow you to modify anything. All you can do is you can say, if I say yes, then it will ask me for the password. Still, I provide the password and I look at it and I see the repository. But the only thing is, if I go and if I try to modify anything in this repository, I wouldn't be able to do. So this is a read-only. I can only see the things. I cannot modify anything. Okay. Why? Because this is repository. This is one that is already being used by the server. So server makes sure that no other process, OBIEE server makes sure that no other process outside it is actually modifying this one. So it creates a lock on this file. So even when you try to open the repository in offline mode and try to do some changes, it won't allow you to do the change. So if you are to open a repository which is currently being used by the server, you can only open in online mode. That's one thing. Otherwise, the other option that you have is you can stop your server. So suppose say if you want to modify 57, you can stop the server. You can do the changes. After stopping the server, if you open this repository in offline mode, yes, you can open and you can edit it. So as long as the server is running, it won't allow. You can stop the server, you can do the changes on the repository and you can restart, then it will load the new changes. So because every time, as I told you, every time you start the server, it will load the repository content to it, right? So you don't need to deploy anything now because this is the repository that is already configured. You restart it, it will automatically load the same repository. So no deployment is required, only restart is required. Okay. So now, the reason I was explaining this is when I actually plan to develop a new repository or modify the repository. So I'm not actually opening 57. So that is the reason I'm saying I'm not opening 57. I have my own copy, or I can make a copy of the 57 by opening the repository in online mode and make a copy of 57, which we did yesterday, right? So how do I make a copy? So I can open online. The blue one is online, so which is you're opening the repository directly from the server. Okay, you're opening the repository, the same 57 now we have opened before, right? So I'm opening the same repository, but I'm opening through online mode, which I'm connecting to the server. So my password is welcome1. My WebLogic password is also welcome1. Okay, now, so suppose say if I want to make a new repository, so I can say copy as repository. So which means I can make a copy of the same repository that is being loaded on the server. Sometimes what happens is, you have access to the server and you can open and you can look at the repository in online mode. But suppose when you want to do some changes, you don't know, you don't have a copy of it. You don't know what is the latest copy, because people might have modified this one, or somebody might have added their changes, this and that. And at some point of time, if I have to get started working on modifying the repository, I need to know the latest copy or something. So rather than running here and there, so what I can do is I can open the repository which is in online mode. I can make a copy of this repository. Suppose say copy as repository. I can give any name. Suppose say repository 001. So I'll just give it as a repository 002, right? Sales repo 002, which I'm making my own copy. Okay, so I made a copy of this repository. Now I can close this. Now, if I want to do the changes, I can open it in offline mode. Sales repo 002 is a repository that I made a copy. So it is exact same as what we have in 57, right? So now I can open this and I can start working on this in offline mode, because it's a new repository. It is not configured, it is not used by the server, right? This is just a new RPD file. Okay, so I open it and I just try to modify this one. So now this time, then if I want to do a kind of any change, I can start working on. So what I will do is I'll simply remove my model. Suppose if I remove my model, all these presentation layers will automatically get deleted. Why? Because when there is no model here, when there is no payment layer here, so there is no point of a presentation, because obviously, right, this is the feed. This is the feed for this. If you don't have this one, obviously it makes no sense to have this presentation there. So anything that you remove, suppose if you remove everything from here, everything from here is gone, because if you don't have this one, you don't have this one. That's it, simple. Right, so now what we have is we have three tables. So probably what I can do is, suppose what if I would like to add a few more tables. So what if I want to add a few more tables to my physical structure, because I have only three tables. So what we can do is we can enhance a little bit by adding a few more tables to our physical layer, then start developing our repositories. Let's try to make it a little more complex, so that we'll get to understand. So remember, and again, the repository tables can be imported anytime. So it's not like where you have to import all the tables in one go and start working on your repository. It's not required. Suppose say now you have imported 10 tables and you build a model, but later you realize there is one more table that is required, or there is two more tables that is required. You can re-import them. That's not a problem. You don't need to mess with the existing tables. Existing tables will be there as it is, and whatever the new tables that you imported, those tables will get added to it. And at the same time, it's not that you have to import the tables from the only one database. You can import the tables from multiple databases also. Same type of Oracle, or different instances of Oracle, or even the total database could be a different one. So you can do any of these different options in importing process. So now I have three tables imported, and now what I would like to do is I would like to add a few more tables. Say the file and import metadata, which is something that I'm going to import my structures. And if I go to OCI, which is my Oracle call interface, and again my service name is ORCL, my user is BA sample, and the password is also BA sample. I think I just need to give you this script. So that is something that I need to show you. I'll show you how to create a base sample schema today, because otherwise, it will be difficult for you to do the exercises, right? I think this schema is already available in the document OBIEE documentation which I have shared. If yes, I think yeah, it is available. Um, I think it's available. Yeah. So if you see, I think I believe I have shared this folder OBIEE to everybody. This is a folder with all the OBIEE related documentation which I have uploaded to the Google Drive, so you can download this. There's a hell lot of documentation which you can go through and use it. Right, so there is a one folder which is called BA sample. So if I go to this folder, then there is a file called, this is the file that you have to download. So this is the file which has the scripts that is required for your BA sample database. You can download this script, and there is a README file where you can README file. Within the README file, it will give you the instructions. So in other sense, there are three files that is available. One is create user file and create schema file. Third is load data file. Three files will be available where we can use. I'll show you, but otherwise, I don't know if I have it. Yeah. Right. If you see here, this is for OBE. This is the zip file. All you can do is you download and extract. So simply download here. Suppose something similar, you download in this folder. Right click on this like a WinRAR and say extract to 7 zip. I mean for OBE. Right, when you extract, and this has a README, and you can read the README. It will give you clear instructions to perform the following steps: create base sample user schema. Okay, open a connection to the database with the DB privileges. Run the base sample underscore user to create base sample user schema. Once executed, verify that you have successfully connected to the user as a base sample with the password base sample. So what is the first step that you're doing? First of all, you're creating the user. So to create a user, how do you create? You cannot create a user by creating a connection to the same user, right? No. So you log in as a system or sys user, which is a DBA privilege, where you can run the script. The first script is what? BA sample user SQL. So which will create what? Which will create a user BA sample in your database. Suppose if you open this particular script. So what is the script is doing? BA sample underscore user script is doing create user BA sample identified by BA sample, which means it is creating a user BA sample with the password BA sample. And again, it is granting all the roles required. So see, these are all the roles that is required, and that's fine. So what we need to do is we need to run this script. So if I have to run this script, I have to connect as what? I have to connect as a system user. So you can open your SQL developer and create a connection with what do you say, with a system user. So then you open this file, then run the file, execute the script. So just to show you how. You simply execute the script that is available here. There is the first script. Then what it will do is it will simply create the user inside your database. Now once the user is created, it means that you have your BA sample user created, right? Then within that user, what do I need to do? I need to create the schemas, which is nothing but tables. Okay, so this is the script that will create schemas. If I double click on the script, and it is going to add all these tables. See, these are all the tables that it's going to add. So first it will drop, and then it will add. It will add all those tables. Okay, that's the second step where you run the script. But again, before running the script, you need to make sure that You create a connection with the user base sample and password base sample in your SQL developer, and from there you open this file and run it, so that the tables are created inside the base sample user. So that's very important. So the first step is you create a connection with the system user and create the new user, which is a BA sample. So that particular connection work is done, system connection work is done. You're not going to use system anymore. Then you create a new connection with the new user that is created BA sample. Then within that connection, you run the schema script. So it will create the tables. Then this is a zip file again. Within the zip file, you'll have another zip file, which is BA sample underscore data underscore 825. Now you extract here. If you extract here, it will create a bigger file, which is 22 MB files. That's the reason they have zipped it. Okay, then you open this file with the BA sample connection again and run it. It will insert the data to the tables. So if I show you, so first you create a connection with the system user, something like this. So now suppose this is my system user. System or sys doesn't matter. Right, so now you can go and you can open the script. Suppose I have my script, which is available in my software folder. Software OBIEE for we. Then I have my script, which is the user script, right? So I have connected as a system user, and I open my. Now all I have to do is simply run the script. So the second one, run a script, it will simply execute and it will create the user for you. So once it is done, then this work is done. So you don't need any system user anymore. Now you need to create a new connection. I disconnect this one, it's not required. So I need to create a new connection with an MBA sample. So how do we create the connection? I go to the properties. Or I mean, if you have to create first one, then you have to go and here there is a green button, right? You can click on new. It will create a new connection. Then the user is connection name can be anything. The user be a sample, password is be a sample. Remember, that's what we have given in our script. In the script, the user is be a sample. It's in uppercase. Password is also in uppercase. So 11G or 12C databases are case sensitive. So if you give the username in lowercase also, it will give an error. So username, password are case sensitive. Okay, so you give that, and this is your host where your database is running, which is the local host, and the port is 1521 by default, and service name is what? ORCL. So you say test, it is success. Now you connect. So you connected with the BA sample user, right? So now you open the script. What is the script that you're going to open now? That is the schema script where you're going to create the tables there. So I go here now and I can say for OBIEE, and I'm gonna open my schema.sql. Now I say run script, it will simply add all these tables into my BA sample user. Similarly, I can open another file by connecting to the same BA sample, that is my data file, which will have all the data open here. Then again run script, it will run statement based statement, it will insert all the data to my database. So that's how you work it out on the BA sample schema creation in your database, so that you can use the data for the development of the repository. Okay, so I mean this is simple, straightforward, and you can as well go through the README instructions. They have given it very clearly. So create a base sample schema, open the connection database with the system or DBA privileges, is clearly telling. Then run the script to create base sample schema. Okay, once execute, verify that you have successfully connected to the base sample user. Okay, then load the base sample. Second step, open a connection to the database with BA sample user. So that's what we did, and there you run the schema. Third, once the base sample schema is loaded, verify the tables have been created from the popular using the SQL command. For example, select count star. I think this is one more step. Tables and data. So both is giving tables, creating the tables and the data in the same step. Open a connection DB with base sample user. To create a base sample table, run this schema, base sample schema.sql. To populate the tables with the data, unzip so and so and run this file. Simple. So now he has given instructions clearly in the README. So I believe it's not a tough task to do. Okay, so now I'm gonna connect to my database with my user BA sample. So I'm gonna import a couple of more tables and say next. And if I look at it here, so I go to BA sample, so there are a lot of tables available, and if I see there are say how many tables imported now, so far 3 tables are imported. So if you see here, these 3 tables are shown as a gray, in the sense it's already imported, so it doesn't let you import them again. But again, so what you can do, you can add other tables required. Suppose if you want any other table, then you can simply add it to your. So suppose I may want a customers. I would like to add a customer. So now see, I'm making sure that I'm not selected anything. So I select a customer and I can hold my control from the keyboard, and I would like to select one more, which is time. Okay, and probably I would like to select addresses if I want. I mean, I can choose any of the tables. They are somehow related to this entire data model. That's fine. You can import any of the tables. But again, let's start with the step by step, and we'll start seeing one after the other. All right. So these are 3 tables that I have, and I say add. So now what is that I'm going to do? I'm going to import the tables that is being selected. Right, so I have how many tables? I have my 6 tables available here. So I'm gonna say finish. So now what I did now, I simply imported my 6 tables that is required by my physical layer. Suppose say 336. Now, so if I look at it here, so now I have added 3 tables, right? Total 3 plus 3, 6 tables. Now what I'm gonna do, I'm gonna see my physical diagram and objects and all joined. So I'm gonna see the relationship between these 6 tables. So if you look at here, the 3 tables are joined because I did create a join on my own, right? So in the earlier when I imported these 3 tables, I defined the join between them. But again, these 3 tables which I have newly imported has no relationship defined yet. The reason being is there is no relationship exist in the database. So database has a plain simple tables with no keys and with no relationships. So now what I can do is I can define the relationship if that I want. No, I can also create something called alias table and define the relationship on the alias tables. That is also fine. So let's create suppose if this is looking too small, then I can make it come together there in one place, and I can start zooming in. So now I get some additional space here. I mean, and at the same time I can look at it a bit bigger. Okay, so now the question is, how do I know which table, how do I join this table? So these are already built in the database. So in the sense, the database is built in a way that there are certain tables, and there is a business scenario that is already being defined. In the sense, this is a revenue, and where revenue and offices, products, time. So they are related, right, in a way. So it's not like they have given some dummy tables or kind of some dump of tables and data where they're asking us to work with that. No, so the scenario is clearly defined, and they have the related tables only. In the sense, they have the tables that is somehow related, and there is a relevant data between these tables. So the sample schema that we have used, it's kind of business data only. Suppose tomorrow if you import some tables in the database from your actual business database, so the tables will have data, and the tables have a relationship. They make sense, right? It's not like you create dummy tables and keep it there. No. So you make sense, and you have the tables for a reason, and data is being used for the business. So the same way here, when I import these tables, it's not like dummy tables, and there is a relationship already exists. There is no direct relationship exists. I mean, in the database tables, there is no primary foreign key defined, and there is no relationships created. As if you go to the database and import them, you don't get any relationship. But again, from the business perspective, yes, there is a relationship defined. All they have not done is they have not created the relationship in the physical relationship in the database, but from the functional perspective. So they've already defined the data in a way that they are related. Suppose for an example, so offices and the product and the revenue. So now when I see these three tables first, suppose when I see these three tables first, if I go and if I look at my revenue, so within my revenue, what is that I have my office key. And so where since I have my office key, I can link it to my office table. Since I have my prod key, I can link it to my product table, right? So that way, these tables within this data, within these columns, they are defined in a way that they can be joined. So even the new tables, even if you look at the new tables, suppose say what is the new table? Customer, right? So if you look at, I should have a customer key. Okay, so now which means it is already known that customer and revenue is linked. Okay, so now what is the other table? Sample underscore time underscore day underscore day. This is your time dimension, where you have all the data that is related to time, like calendar, month, day, week, and all those stuff. Okay, so now if you look at here, and so I can use any date. So I have a couple of dates here, like bill date and kind of ship date. Okay, so I can use any date, and what is that? I can define it as a key in here in the time day. So I can use my calendar date as as a column where I can join. So I have my calendar date there, and now I have my bill date. So I can see. I mean, so when you're joining, right? So it is very important to have the same data types. So if I join with the different data types, then it won't kind of get joined, right? Because the data type has to be the same. Because at the end of the day, when you're saying join, it means that you are looking for a common data join, right? Okay, I have this. So somehow, my data is already provided in a way that it is related. So suppose let's see the customers and the addresses. If you see the addresses, and I have address key, okay, and do I have the same address key in my revenue? I don't have any address key in the revenue, but where do I have address key? Do I have address key in my customers? Yes. So which means my customer table and my address table are related. So it is not directly related to the revenue. So somehow the relationships are already there from the data level and from the functional level in the BA sample. But all we don't have is we don't have direct relationships created in the database. It is done intentionally because we get an opportunity to create relationships on our own, so that we get to see how do we define the relationships inside the OBIEE on our own. Again, so it's not that yeah, I always have to follow the relationship that is available in the database. I can create my own relationship contrary to what is there in the database, as long as I feel that with this combination we can pull some data. Because when I define a relationship between the tables, so all it looks for is what? Data type compatibility. So if I have a date, I can join to any date, or if I have some number, I can join to any number, any column with a number. But that doesn't mean that with these two combination of columns, I can pull some common data between these tables. If I'm not actually pulling that common data, it makes no sense, right? So when you're defining, you can define your own relationship inside the OBIEE other than what we already have in the database. That is pretty much possible, but making sure that your join or your relationship will fetch some data while when you query the tables actually. So that is very important because defining a model is fine, you can define it, but again when it's not the data combination, the join combination that you have defined in the physical table, if it is not fetching any data, what is the point of defining a join? That is very important. So understanding the data, understanding the tables and how they're related is very important. So I mean you don't need to panic, how do I know all these things, and uh, so how do I know how this table is related to the other table in real time, if I tomorrow if I work on the project, so how do I get to understand all these things? See, I mean it's not that they'll push everything on you and say that guys, okay, get that going. So they don't give you everything to you and say that develop. No. So there are different roles in the organization, and it's your not job to understand what are these tables and how these tables are related, and also the provided there is a data that is available in the database, they'll provide you the data model. So if there is an architect will define you all these things. Okay, so an architect will tell you where do we get the data from and all the stuff. So as a developer, so you'll not be taking decision at the level of how the relationship should look like and all. So they'll guide you, and based on that you will be doing. It's not that you are the sole owner of this entire setup, and you will be kind of wearing multiple hats, understanding what to be created. No, it's not that you alone. So it's a group of people that will be working on that. So don't think that you have to struggle yourself on all these things, because at certain situations it's not that you alone will take decisions. Because in the suppose say now, take a simple example. So I'm a developer. Okay, assuming that I think myself as a smart guy. Okay, so I say that I know everything. I know what is required for you. I'll develop something and I'll give it to you. Suppose I think I'm right, but at the same time, it doesn't mean that whatever that I created is useful to the requirement, right? So so they don't leave everything on a developer saying they can develop whatever that you think is right. It's not going to work. So there is a very much a clear definition of what is that we are going to use. I mean, what is that model that we are going to create, and how many facts, how many dimensions, and the relationships and the measures that is going to require. Everything is documented. Okay, everything is provided. So what needs to be done? Okay, so that way you are pretty much covered in terms of providing what is required. Yeah, sometimes they give the task to you. So probably at least even though you are the one who's looking around and identifying the things and creating the document um, with that required things, but at the same time you get an opportunity to discuss with people and take their opinion, saying okay, I'm going to add these 5 columns or 6 columns or 10 columns as a calculations. Okay, is that fine, kind of stuff. So now that way you before you actually start developing the things, you kind of upfront know, or you have the details in your hand, so that it's easy rather than opening that's very very difficult task. So no, one thing that I don't want you guys to start doing is create a repository, open the repository and start thinking what to do. That makes no sense, because so probably technically you are one step ahead, where you open the repository and created a new repository. But the thing is, unless you know what you actually want to do, so if you don't have a clarity of what you really are planning to do, that's make things complex, because you're confused there. You open the repository, now you start thinking what to do now. So rather than doing that, just have an idea, take a pen and paper and see, okay, what you planned it. Okay, I have these 4 tables. Okay, these are 4 tables, and again, I'm gonna define the relationship with these 4 tables, and they are related this way. Okay, then I'll do this, and then I'll create a few columns or few measures, and so you have a rough sketch with you. So just start implementing by using that rough sketch. That way, um, you're thinking what you are doing. So beforehand, you have a plan and you have an idea in your mind. So what needs to be done. So that makes sense. So to make it simple, and I'm gonna create the relationship between these tables, which is the new tables that we have. Okay, so I minimize this. See, expand, it will expand the tables, and if I say minimize, it just display the name. If I say auto layout, it will put all of these things together. So probably now I can say zoom. I can zoom these tables to some extent. Right, so I have my products and I have my offices. Because I'll put my time here, I put my customer here, so somehow I put my address here. Because I know because this is how they work. So now I'm gonna define the relationship between my revenue and my customer. So what does it mean? So I would like to analyze my revenue with respect to the customer. Okay, so again it's a one to many. So customer is on the one side and the revenue is on the many side, which means one customer can generate many revenues. So which means I as a customer can go and buy the goods from the store more than one time. So a customer may have a number of transactions where you might have shopped 100 times in last 1 month. So that's pretty much possible. So one customer can have many transactions in my revenue table. So that's the relationship that we are going to define. So if I'm defining the relationship, you have to start from the many side. You have to start from the many side and drag it to one side. So that's a little weird, but again, I don't know. Oracle has come up with this approach. So if you start from here and connect to here, then this is on the many side. This is on the one side. That will be the reverse of what we are actually planning to do. So, but again, so now you may be thinking like, how does it make any difference? Yes, it makes difference because in a multi-dimensional model. So when I'm defining a multi-dimensional model, fact dimension and all, what table is the fact table, what table is the dimension table makes a lot of difference. Suppose say if I say revenue to customer, so this is a many revenue on the many side, customer is on the one side. Suppose if I connect from here to revenue, so my customer is on the many side, my revenue is on the one side. So this way, what it becomes, the table that is on the many side becomes a fact table. So, but in fact, my customer is not a fact table; it's a dimension table. Right? So that way, no, I mean, I will discuss what is a fact and dimension, but the relationships, if we do not do properly, the model is gonna be like a big mess because you are having a tables which has being shown as a fact tables, though they have some textual information. So the table that is on the many sides, so you always connect from here to here. So if you look at here, even this relationship show you the same thing. So this is one. What is the one? This is your customer. Customer is on the one side. If you see the cardinality, customer is on the one side, and the revenue, if you see the revenue is on the n side. So customer is on one side and revenue is n. So if you see the relationship, customers dot address key equal to revenue dot. Okay, it's see now it's showing the wrong relationship. Why? Because in customer I don't have a key. If I already have a key available here, then it will automatically select that key, particular key, address key, and look for the same key that is available in the other table and automatically define the relationship. But in our case, there is no key defined in the new tables. That is the reason, it's not actually automatically identifying the relationship. So now what we can do, we can give our own relationship. I can define so customer key, and within the revenue, I also have the customer key. So now I define my join on my own, so rather than letting it understand automatically. So with this process, the advantage is since you selected these two columns, it will automatically create this customer key in the customer as the primary key. So you don't need to go and create a key manually. If you manually select the relationship, and if I go back to customer, my customer will automatically get created with the key. Okay, I'll show you probably. Where are the customers? See, the customer has already got a key. How? Because I define the relationship. The first thing it will do is it will create the key first, then it will define the relationship between these tables. Okay, so otherwise, there is no key. Suppose if for example, so for this also there is no key defined. So now if you define the relationship, you'll automatically define that as suppose a calendar date. So there is no key defined. So calendar date, there is no key defined. But if, once you join it right now, it will automatically uh, mark this as a key. Okay, so now I have 4 tables which are part of relationship, and I would like to add the other 2 tables that we have. So this is my offices, and I would like to define my time. So obviously, again, the relationship is between the revenue and the time, because revenue is on the many side, time is on the one side. So again, it will struggle to define the relationship automatically because I don't have a primary key defined on my table. So there is no common column that I'm explicitly saying, okay, this is the common column. Suppose at least if I give some column here, then it will automatically look for the similar column here. If I don't have the keys in both the tables, then it will give some random relationship which may make sense or may not make sense. Okay, so now here I have my bill date which I would like to use in my revenue. So I would like to analyze my data with respect to my date of the billing. Okay, with my calendar date. So I'm gonna within my calendar within my time dimension, I'm going to using my calendar date, and which is I would like to verify against my bill date. So this is the relationship. If I say okay, so I have my relationship. If I look at here and if I say, so my calendar date is being automatically defined as the key. Earlier there was no key defined, right? So I define it as a key, and I go create my model again. So if I look at here now, this at this point of time, I have all the tables. Now I need to join my what do you say, customer and my address. So now if you look at the relationship, one customer can have many addresses. A customer can have many addresses. Who's on the many side? My address is on the many side. That's how you need to kind of think before you actually define it. So you need to understand the business relationship. That is very important. Suppose say customer and the address. So what is the fundamental business relationship between the customer and the address? Okay, many addresses. So I mean, one customer cannot have many addresses, right? Mm, One address can be with many customers. No, yeah, one customer can have many addresses, obviously, right? So suppose say I have my place, or I have my. I mean, when I'm a customer, so I can define multiple addresses, right? So I can say billing address, shipping address, okay, payment address, whatever the different addresses that we have. Suppose it. So one customer can have many addresses. So which means address is on the many side, customer is on the one side. So if I'm defining the relationship, and I define the relationship between these. So now, so so how they are related? So they are joined with the address key. I define the tables with my address key. Because if I select my customer key, and it makes no sense because there is no customer key available. So I'm going to join these 2 tables with my address key. So this is how my relationships are defined. So it's little confusing to start with for you, because when you're defining on your own, so you find it a little confusing. But again, so all you have to do is kind of your thought process cannot go to this level and imagine everything. What you have to do is you have to start developing the things, start working on the things. So if you open the repository, if you create the things on your own, you slowly start realizing what you're actually doing. So otherwise, this kind of may confuse you a little bit, right? Now, so I have my tables that is defined, and I have the relationship defined between the tables. So it's not mandatory that I have to define the relationship in the physical tables here. Whereas I can simply import them as it is, but again I can define the relationships at the alias tables level. So now there is one more tricky thing that we are going to do is we are going to build something called an alias tables, which is on top of these physical tables. So what is an alias table? So alias table is kind of, um, it's a physical table only. It's a table only, but again, it's not a physical table. So we are giving a different name. So it's kind of, if you remember our base SQL, when we're writing SQL queries, what do we do? Select star from EMP E1. So what is this EMP E1? So E1 is kind of an alias for my employee, comma EMP E2. Why am I doing like EMP E1, EMP E2? Suppose if I have the same table EMP, if I would like to use it for a self join, like if I have to use the same table to join on its own, I mean within it, and now if I have to pull some data on the table, then I can use my self join. So that way, I can give the same table with a different aliases and I can join them. But again, see, the purpose here is, two things. Sometimes, my table name is very big and, that's not actually making the name of the table is not actually making sense. So then I can type that name and I can give a simple alias where I can easily understand. So why we create alias tables? One is, it's kind of, alias is a reference, right? So even, so does any table called even exist in your database? No. Does any table called E2 exist in your database? No. So it's kind of, one logical table or like a reference table that that database builds internally. I mean, you are not actually defining anything. You simply say EMP E1. Now database automatically create a internally in the kind of in the query execution time. So it will create a structure in the memory where with the structure name E1 and the structure name E2 and join these two tables and pull the data, right? The same way here, when I'm defining my OBIE, so there are times that, I may want to use the same table more than once. Like, I have used DMP E1 and E2 because it could be a self join, or it could be that, I want to join the same table with two different tables with two different type of joins. What does it mean? Suppose say, take an example here. I have a table time, assuming. So my time table is linked with revenue table based on a bill date, which means if I use this combination time table and the revenue, so when I do a query, my information is always based on my primary foreign key, which means I'll be pulling the data based on these two tables based on a bill date. So whatever the data that I retrieve, right? So that is based on the combination of the bill date between these two tables, right? So, okay, that is one combination. So what if I want to get the combination of the data based on the ship date? Obviously, right, bill date and ship date are different, and if I do a query between bill date of my time dimension and date of my revenue, I may get 100 records. If I do the ship date, and probably I may get 200 records. So the query is different. The data that is being retrieved is different because the combination is different. So now the requirement is I have my revenue, I have my time. I cannot have two joins, right? Can I have two joins? No. I cannot define bill date and a revenue join, and I cannot define a ship date revenue join. I cannot have two joins between the tables. So what is that I need to do? I need to have one more table of time table, because if I have one more table, what do? I simply define a new table, and from that table I will define the relationship to revenue, where I can define my own relationship. So which is based on the ship date. So which means my revenue is linked to time, two timetables, one with the bill date, one with the ship date. So, but again, the table is the same. The timetable is the same. The data is the same. We're not going to create a new table, or we're not going to have different data. It's the same data, but the combination is different. In these scenarios, like EMP1, EMP2, where I want to use the same table for multiple purposes. So rather than creating the physical table again, because if I create the same table time again in the database, unnecessary it's work, and at the same time it's unnecessarily we need to maintain the data in two places. So every time you do some changes to the time, you have to go and update the two tables. So that is like unless that is kind of useless, where it's not going to help you in any way, right? So what we do is, so OBIEE has introduced a concept called alias tables. So the table will be the same, but you can create a table like something like this. You can create a table, or you can create as many aliases as you want here inside your OBIEE. So the moment you create alias, right? So one table I can create four aliases. So now I have the flexibility of joining those tables in whatever the way that I want. So the best part of alias is the moment you create an alias on a particular table, the keys are, on the alias table, it won't have a key, which means whatever, suppose say in my time dimension, suppose if my key is a date, so when I'm joining, most probably I'll be using this key, right? So my all table joins for this table is used with the calendar date. But the moment I create an alias table, what it does, it will remove the key, it will create a new table. So in the sense, the key will be there on this table, but alias table can have its own key. So though it is a reference table, the advantage is the alias table can have its own key compared to what you have in the physical table. So my physical table may have particular column as the key, but I can define my alias table, and on alias table I can define my own key. So that way, that is very important, right? So key is very important. Based on the key only, the data extraction, the relationships are defined. Okay, so what we do here is we create alias tables on all these tables. Technically, the reason being is, we never know which table we may need at what time. So probably, after, so I created a repository after a month or 2 months, and after a year, I may see that and there is a new combination where I need to create. So rather than, um, kind of going back and forth, and at some point of time realizing, you need to modify, then rather than doing that way, as a standard, we create alias tables for every physical table, so that now we start with the alias tables. Then even after a year, if there is a change also, when I say change, um, if I want to create one more table, I can create one more alias table. So it's not like I don't want to define my kind of physical layer relationship, saying on some table, some of the tables are alias tables, some of the tables are physical tables, and I'm joining these. It's kind of a big mess, right? So what I'll do, I'll keep my physical tables away from this stuff, and I define the relation. I can create an alias table for every table, and I start defining the relationship between them, and I start using that particular tables when I'm modeling my BMM layer. So that way, tomorrow if you're adding another alias table, that actually fits into the your set of things, rather than one table I'm using alias table, one table I'm using my physical table. So that makes no sense. So how do I create an alias table? So I can suppose I'll start with my products. I select my product and right click, new object, alias. So what is it I'm doing? I'm creating a new table, which is my alias table, which is my product. I say alias. So now, what is the name that I would like to give? I can give any table, any name. So it doesn't really push you. Um, what I would like to give is, I say, I can give it as 01. See, alias is another advantage of the alias table is, you may have some weird name for this particular table. Suppose sample underscore product underscore this underscore that underscore. So there's a very big weird name where, it, by looking at the name, it's not even making sense what it has sometimes, because table is a technical, right? So at the database level, you define some standard, you define the tables with that naming convention. So they're not really, may not be making any business sense at times. So those times, at least, you rather than seeing some tables which you don't understand what they are for, it's always good to see that, the business names. Okay, this is the product table, this is the customer table. So that makes sense, right? Suppose say if I have like a table like an A14356. So the table name itself is A14356. Now, how do I know what does the A14356 has? Now, if I create an alias table instead of looking at the A14356, I can look at the alias tables with a proper name so that, okay, yeah, this is a product information, this is a customer information. Otherwise, always I have to keep a dictionary, A14356, then I have to go to an Excel sheet and search A14356 and say, okay, this is the customer table. So that makes no sense. Okay, so I'm going to create an alias for this particular table, which is, I call it as, products. Okay, this is my products table. And see, if you look at this here, the advantage with the alias table, so this, I created my alias table. So this is my products table. This is my alias table for the product. So if you look at here in my products table, what is that I have? I have my product key. So if I look at this table, I don't have any key, which means whatever that the key that I have in my physical layer, that key is simply removed, simply ignored. It will create a new table with its, it will create a new table which is an alias table with no key. There is no key defined here, so it's empty. Okay, so now that is an advantage of the alias table, where you have a new table available which you can join to any other table with your own combination to pull the data. So that's an advantage. Okay, so now I have my alias table created for products, and similarly I'm going to define alias tables for everything. So I can say new alias, I can say 0 to offices. I can also define like in which tables to come first, which tables to come next. Suppose say probably now I can see D2. I can say otherwise we can do this way, D1 D2 kind of stuff, rather than saying 0 1. I can say D1 D2. So D2 is my offices, so probably I can rename this alias table as a D1, which is a dimension 1. If I think like product should come first, if I say offices should come first, then I can say office as a D1. So I can I can make sure that they are kind of in a sorted form. So why do I really need to have? Sometimes suppose say if your data is coming from operational system, OLTP. So suppose say for product I may have 5-6 tables. Maybe there is a product table, there is a product brand table, and the product description table, right? So there could be 5-6 tables where you will be importing into the physical layer. So unfortunately, I have only one product table here, so it's possible that there are 5-6 product tables. So now when I'm defining them, I want to group all the product tables in one place. So suppose the naming convention should be in a way that if I look at it, I should see all the product tables in one place. So that makes sense because all the products tables one place, and all the related tables we can keep as a group, so that when you are working on that, right? So I don't need to really run around and list all the tables that is related to product, and then I start seeing like how they're related by connecting them, by selecting them. So that's kind of yeah, you can do it, but it's not easiest way of doing the things. That way, the best option is to create alias tables with some sequence or some sorting sequence, so that you can see the tables with your own naming convention or your own sort order. Okay, so I have my products and I have my offices, and I can create my revenue. So alias for revenue. So now since my revenue table is a fact table, I can say F1 revenue. Okay, so I created my F1 revenue. Now I would like to create a customers. I can say customers, new alias for the customer, and I can say D3 customer. I'm defining dimension. So now see, because I have given D3 and it's in the same sequence, so it's, though I have created a revenue first, but it's not really worrying about it because it's going to display the data in the sorted form. So I can select my time dimension. I can so say alias and I say D4 time. Okay, and I can say D5 customer. Okay, how many tables I have? Three, six. 1, 2, 3, 6. I have 6 alias tables now. Finish. So now what I can do is see the beauty is if you define alias tables and suppose I select these tables, physical diagram, selected objects only, which means I would like to see the relationship between the objects that I've selected. So what is it I've selected? Only alias tables. If I see the relationship, there is no relationship available at all. I created a customer twice. Okay. Again, what is that I missed? Addresses, I believe. Yeah. Probably, yeah. Right, so I'm going to select these tables and I'm going to define the relationship between these tables now. So because the moment you create a alias table, the existing relationships, existing keys, everything is simply ignored. So they'll create a plain table. So now I define the relationship. So now, as I was saying, um, so if you're planning to create an alias tables, and then there's no point of defining the relationship between the physical tables. You don't need to. So you can keep the tables as it is without the relationship also is fine. Okay, but again, so anyway, I created the relationship between them. But again, even if you keep the tables without the relationship and start creating a alias table for every table, then defining the relationship, yes, that works. So physical diagram and selected objects only. So these are the tables that I have. Okay, so I'll keep it closer. So now again, so the relationship is kind of the same, but again, you can define your own keys now. But at the same time, or you can, as I told you, as I told you, like if you um, connect the columns, if you already know, and if you connect the columns the way that you want by selecting the primary key and the foreign key, then the keys are automatically created. So I don't need to define keys manually. So I'm going to define my relationship between the offices and the revenue. So I can connect from revenue to office. It's many to one, right? So many. So now this is my officers table. So since there is no keys defined in my alias table, so I mean it's not that now I have to define this way. I can go and first define the key there and come here and define the relationship. The only advantage is if you define the key there, then it'll automatically select the relationship on its own. So you don't need to select it manually. But if you select it manually, and it will automatically define a key. That's an advantage. So I have an office key, and I'm going to link my revenue with my office key. Okay, this one. Now I have my revenue and the products, my prod key, and here also I'm going to choose my key, which is my prod key. Okay, I have my customer, so I have a customer key, and I should have a customer key here. I have revenue to the time key, so which is my time. I have something around a calendar date, so I say bill day date. I mean it could be bill day date or ship day date, it's up to you. But again, remember, if you define ship day date, then any query that you make between these tables, that will be pulled based on the combination of calendar date and the ship day date. So your choice, but any date should be fine here. See, again, remember, you don't think that the column name has to be the same. So now say I have my calendar date, so I should have a same column name calendar date to define. So you don't need to. You have to have the data matching between them, or at least the basic fundamental what it says, data type should be the same. Okay, so again, whether it has a common data or if it has a matching data, it's making sense to the business and all, it database doesn't really worry about it. It's your responsibility when you're defining the relationship between the two columns and you say that they are related from the business perspective, which means when the moment you say that they are related from the business perspective, there is some data that is matching. That's what it does, right? Suppose say like in a customer and the address, or product and the revenue. So there should be some common data because I'm expecting my revenue for the product. So in the revenue table, I should have some details about the revenue that is being generated for the product, so that I can analyze those things. Um, so I define the relationship based on what is the data that I have and how do I actually pull the data. Okay, so now one customer can have many addresses. So many is on the addresses and the customer is on the. Okay, this is address key. This is my address key. Right, so this is how I build my model. So this is the kind of an alias table. I build physical tables and their relationships. So now don't think that you have to do everything in the BMM layer. So we'll do the basic things in our physical layer only. So we kind of creating alias tables. If you see here, all these tables is having primary keys. So did I create any of these keys on my own? No, because I have defined the relationships between the tables and um, kind of the keys is automatically created. So now all I need to do is now everything that I do, anything that I do in my BMM layer, I always refer back to my alias tables only. So the advantage here tomorrow, if I have one more table, suppose a time table, if you want to build one more alias for the time, new alias um, 05, right? 06 time um, build date. Suppose I'm just giving some dummy name, so build date. So now this is my alias table. Now, if I would like to see time and revenue, so I am selecting only these three tables. Okay, just for an example, so I can say physical diagram and selected objects only. So now what I can do here is I can define the relationship to the time, and I have one more time. So now I can join my revenue table to my bill date. So now here, so I have my calendar date in my time. I can link it to ship date. So now which means the combination is like you will be getting data from the ship date combination. So when you do a model, when you query these two set, where you get the revenue that is related to the bill date, ship date, and this get to the bill date. So same table I'm using twice without replicating it, without having two physical tables in the database. I have only one physical table in the database, but I have created two alias tables that I defined. So that's how anytime now you would like to add one more table, you can add it with, and you can define a different new relationship and start pulling the data. So that flexibility you have. Otherwise, what happens without the alias table? What happens? Now you don't have alias tables. Now this is a physical table. You create one alias table. Then some of them are physical tables, some of them are alias tables. You totally mess it up. So that's the reason you build alias tables for all the physical tables that you're going to use first. Then start building the relationship between those tables and start using them. Okay, that's how my alias tables work. So I simply save this one, and since my repository is not done yet because there is a BMM model that I need to define and there is a presentation layer that I need to define. So if I say consistency, it's no good, right? So it's not going to say that it is consistent, because without the BMM, without the presentation layer, it is inconsistent always. But it doesn't mean that you cannot save it. You can save it. So you want to check the global consistency? I say no, because I know that it's anyway failed. So, but I still saved it, right? So I can open it later point of time. I can start developing the things. Okay, so we'll develop the model tomorrow, and we'll try to see how do we create a model from the scratch, like creating the facts and dimensions on our own, and creating the columns and defining the logical table sources and defining. So you drag and drop, you get everything. But again, I want you guys to have understanding of how do we define from the scratch on our own, so that you understand how they are actually built and how they're actually related to one another. So tomorrow when you get a requirement, a complex requirement to modify or do some things, then you have the flexibility of doing the things in your own way. Okay. Right, guys. So any questions before we wrap it up?